Alright, last video for section 1.5, and it has to do with even and odd functions. So our objective is to learn and apply the definition of an even and an odd function. I'd like to refresh your memories on something that we talked about in the last section, and that is symmetry in the graphs, when it's symmetric about the y-axis, the x-axis, and about the origin. As you went through that, you may have noticed some little shortcuts that help you determine whether or not a function was symmetric about the y-axis. And I hope that you did, because this section will kind of address that. First of all, an even function is a function where for each x in the domain, f of negative x is equal to f of x. Okay, that's a situation where it is symmetric about the y-axis. What this is saying is, when you plug in negative x into the function, out pops the original function. It doesn't change. Okay, and that's what we did when we were doing symmetry in that last section. An odd function, if for each x in the domain f of x equals negative, f of negative x equals negative f of x. If that's true, then it's an odd function. So what this is saying is, when I plug in negative x for all the x's in the function, it turns out that I end up with a function that's exactly the opposite to the one I started with. Every sign is the opposite sign that it started as. Now those are a couple of things that you may have noticed when you went through those problems before. Yeah, you may have discovered a pattern to help you determine whether there was symmetry based on the exponents in the function. Okay? Because whenever we plugged a negative x in, if x was squared, it went back to being positive. So when we took a negative x and we squared it, it was back to being positive. On the other hand, if the negative x went into an x with an odd exponent, then it changed the sign. Okay? So notice, when it was an even exponent, the function didn't change. When it was an odd function, when the exponent was odd, then it did change. Okay? That's where the even and the odd comes from. So this is why we also use even or odd to describe the functions. If a function, when I talk about an even function, I'm talking about all the x terms have to have an even power. Okay? And when that happens, it's symmetric about the y-axis. And when I talk about a function being odd, all the x terms have to have an odd power. If at any point you have a function where there's some even powered x's and some odd powered x's, then it is not symmetric. Period. It's not symmetric. Now, one last thing. It'll come up in this example. Here we go. Y equals 3x to the fourth minus 2x squared plus 3. So when you look at that, you have an even power and even power, and so naturally your thoughts are that this is an even function. But what about this? Do you know? Well, this function is even because a constant added to an otherwise even function does not affect it. Okay, so in this particular example, this doesn't affect whether or not a function is even. It does, however, affect whether or not a function is odd. Okay? In this second example here, we have an even power there and an odd power there. So that in and of itself is enough to tell you that it's not even or odd. Second thing is that last constant that's being added there. That constant does affect odd functions. And it may seem confusing, but I'm going to make it simple in just a second. Okay? So that function, because it has an even and an odd power, is neither. I want you to think about this. What is x to the 0 equal to? The answer is 1. X to the 0 is 1. And wouldn't you also consider 0 to be an even power? Because now when I have this 3 here, I can think of that as being 3x to the 0. And now I have an even, and an even. If I put an x to the 0 here, I have an even and an even, but here is an odd. Hopefully that helps you understand the constant at the end. Think of it as 3x to the 0. All right, let's try another one. Y equals 3. Isn't that a strange critter? What are your thoughts? Even, odd, or neither? The function is even. And in order to understand it, I want you to think about what the graph looks like. Remember, an even function means it's symmetric about the y. An odd function means it's symmetric about the origin. Okay? The graph of y equals 3 is just a horizontal line. Isn't this a mirror image of what's over there? Isn't it symmetric about the y-axis? You bet. Okay, last example. Well, 5 is odd, 1 is odd, the function is odd. And that's it for even and odd functions. For my sign off today, I'm going to say, bye!